a German sociologist wrote his book, Risk Society, pointing out exactly that we are in a different society. We are living a different modernity, which is characterized exactly by a lot of turbulence. This world is also called the VUCA world. VUCA means volatility, uncertainty, complexity, and ambiguity. This is how it was called in the early 80s to describe this big change of the world that had become more volatile, more uncertain, more complex, and more ambiguous. Now, in the 40 years later, in the 20s, this VUCA world went on, but it started showing other manifestations. Namely, volatility has become a sign of fragility. Uncertainty has led to anxiety. Complexity has led to non-linearity. Ambiguity has led to incomprehensibility. The people that were concerned about ambiguity now feel the world is not comprehensible. And this is now called the BANI world, B-A-N-I world. Brittle, anxious, non-linear, and incomprehensible. Brittle means that something that is very fragile. It looks rigid, but when you touch it, it breaks away. So our society is also a BANI society. Now, what skills should we all, but mainly our engineers, have to live and to act professionally in a VUCA BANI world? These are some skills that have been pointed out: autonomy, leadership, curiosity, initiative, resilience, creativity, teamwork. You know them all. That's the major skills that are required. So we should be concerned about this in the education of our engineers. Now, how can we prepare the engineers of the future for these skills together with their professional preparation and theoretical and practical preparation? For this world, how should we do? What should we do? How should we go about? The problem is that no one has any idea what the next decades will be like. So what does this mean? It means that the engineers of the future must be prepared to adapt. They must be prepared to build their own roadmaps with autonomy, determination, and imagination. They must be autonomous, empowered, and proactive. That's our agenda. That's something we must be concerned about when preparing our engineers. How should we educate them for this? For what types of engineering should we educate them? What cultural context should we give them in our schools? What pedagogies should we use? And I'll try to answer very quickly to these three questions. So I'll begin here by exactly talking about three types of engineering we are facing. The cultural transformation we need to carry out in our universities, and the pedagogical transformations we need to put in practice. Beginning with the three types of engineering. Now, the nature of this VUCA BANI world as a result of globalization, climate change, the pace of technology, rising dependence, all this is changing, and it is exploding the number of independent variables characterizing this world. And this results in very complex social, technical, and socio-technical systems. Our systems, the difficulty, the problems, the turbulence of our world today results to a large extent from the technical, social, and socio-technical features of this world. Now, there are two main problems making these things difficult. One of them is that lots of people disagree, and the disagreements between people can have very tragic results. In the past, engineering teams were very small. Today, the teams in engineering are very large, and they are often multidisciplinary, and they involve multiple partners and stakeholders. So it's much more complex to come to agreement. Then, in the past, the interests of the people and of the institutions were people who were not related to engineering were of little relevance. Today, everyone knows what is happening with engineering and what engineering is doing. So everyone has a word about it. So the result is that today there are lots of disagreements between the various stakeholders, and this makes projects very difficult and very different as well, because we need to cope with the claims and the complaints and exigencies of these stakeholders. This is the problem of disagreements. Now, the problem of uncertainties. Now, because of the social, economical, and political features of our world, the reality is very complex today and very uncertain. So we live in a world of uncertainty. And this happens to a large extent because of the human intervention, and because the humans have changed the behavior of the nature, and it's becoming very unpredictable. So these are the uncertainties. One of the problems is that lots of problems today are called so-called wicked problems, which is problems that are so complex that we are not able to describe them. We need to start solving them until we finally start to understand what they are all about. So increasingly, the problems of our times are becoming very complex, and many of them are becoming wicked. And this makes engineering very difficult to develop. Then these two dimensions, disagreement and uncertainty, can be drawn on a referential and two axes. If we draw this referential with certainty here in this point in the origin, and uncertainty to the right, and with agreement in the origin and disagreement here, we'll have a space where we have here a lot of certainty, we have here a lot of uncertainty, we have here a lot of disagreement, and here we have a lot of disagreement and uncertainty. This is a diagram that was proposed some years ago by Ralph Stacey, and it's very useful for me to point out now how engineering is changing because of uncertainty and because of disagreement. In this area, the area of high agreement and the high certainty, we can exercise traditional engineering. So we can explore causal relationships, we can apply general principles, and we can safely predict results, because causal relations are very easy to sort out if we are in a world of lot of certainty and agreement. But if we move here, in this case, now we have a new area, because there's a lot of uncertainty and a lot of disagreement. And this is a new kind of engineering. Some of the problems, sometimes most of the problems, are wicked, and we look more for solutions and for results and for opportunities than to solve the solution of very specific problems. And problem formulation and problem solving tends to become simultaneous. Also, a problem is that there are very little causal, or there are multiple causal relationships. So it's very difficult to conclude here. And for this reason, it's very important to have creativity, intuition, and debate and teamwork for people to discuss and adapt to the difficulties in pinpointing the causal relationships. And there must be a room for exploration and discovering and transforming and creating and innovating. That's the feature of this part of this diagram. There are two specific areas, this one and this one here, which need some attention, because in this case, we have a lot of certainty, but we can have considerable disagreement. When we have a lot of certainty about the conditions of our work, but people do not agree, we have some problems because we have a lot of certainty about the environment, but people don't agree. So they can disturb the solution to the problems. So it requires negotiation, this requires consensus, and this requires support. That is, our engineers to act in this area need to be very good negotiators and need to engage in very close relationships in the solution of the disagreements. Now, in this other area, we have agreement. So it's the contrary. Here we'll have a lot of agreement, but we have considerable uncertainty. Now, in these cases, this requires a shared vision. This requires that the engineers mobilize the various people to develop a sense of mission to try to fight the problems of uncertainty. And there are lots of open outcomes. So this is a quite difficult agenda for our younger engineers. Now, this area is the area of predominantly technical and scientific contexts. This area is predominantly socio-technical. The problems are not only technical anymore. They have a lot of relationships with the people, with the social aspects. And here, in this area, it's impossible to solve problems. It's the area of chaos and anarchy, because there's so much uncertainty and so much disagreement that there are no problems that we can solve. Now, here, as I said, we have traditional engineering. In this lower part of this region, we can combine engineering with the social sciences. But when uncertainty and disagreement become very high, in this situation, it's usually better to try to survive with the complexity of the problems, to work on them not by decomposing them in parts, but grabbing the whole complexity of the problem. So this is an area for problem solving. This is an area where engineers converge towards outcomes, and is an area where engineers and all the other stakeholders try to find and develop emergent solutions. This corresponds to what I called before the three types of engineering: traditional engineering, socio-technical engineering, and complexity engineering. So these are the three types of engineering for which we need to prepare our engineers, our students. Now, moving to the next question, what cultural transformation should we carry out on our schools, on our universities to teach these engineers? We need a culture of engineering education that's prepared for turbulent times. We need to prepare for change. So this is one point. We need to prepare them for change. We need, for this, we need to strengthen the interdisciplinarity of the approaches we take to education. We need to combine technical knowledge with critical thinking and creativity and adaptability. And we need to upgrade our pedagogical approaches so that we can expose the students to unexpected and ambiguous situations. Another aspect, we must foster resilience, must increase hands-on experiential learning. We must develop project-based learning, and we must invite the students to solve a lot of real-world case studies. We must develop problem-solving skills. We must encourage learning from failure, and we must cultivate in our students a growth mindset. Third, we must encourage entrepreneurship. We need to promote an entrepreneurial mindset, empowering the students to identify the problems and explore new solutions. We must incorporate design thinking, which I'm afraid we do not so much do. We must promote collaboration. We must provide opportunities for a lot of prototyping and experimentation. Fourth, we need to inspire lifelong learning. The students must be prepared to learn all the time. We must develop an attitude for lifelong learning and instill a passion for continuous growth. And we must encourage them for a positive disposition towards autonomous learning and to understand and explore the technological advances. I give an example. Now, suddenly, since past November, we start being faced with artificial intelligence and large language models. And our students must be already experimenting with all those potential technologies and start using them. They must adapt very quickly to the technological advances. Fifth, we must stimulate them for the ethical dimension. We must emphasize the need of ethical decision making. We must emphasize social responsibility, and we must emphasize sustainable practices. And we must provide knowledge and tools so that they can anticipate the ethical implications of their action, and so that they can make informed choices for the general good of society. And that's in 3 points what I feel is important as the cultural transformation is concerned. Finally, the pedagogical transformation. I believe very strongly that we need to transform radically the pedagogical approaches in education, in higher education in general, and engineering education in particular. Now, how can we make this transformation? I've been working in this topic for about 40 years, so I'll try to summarize a bit my concerns in this respect. But I think it's worth noticing that the mission of engineering education is today much more complex than in the old days, because today, in the past, we just needed to impart cognitive knowledge. We just needed to tell them theories and to let them learn theories and apply the theories. Today, we must also develop competencies, and this is much more complex. And we must prepare them to develop the competencies in combination with the cognitive knowledge. So this is much more difficult. And the engineers, most of the professorate in engineering are not used to do this. Then there are the problems of the new dynamics that need to be explored in the classrooms, and including the transition, the permanent transition between face-to-face and online. So we also need to develop the proficiency of the professors and teachers in higher education for the advanced technologies that are being developed. And we need to adapt them. We need to prepare them for this complexity and uncertainty and turbulence of our times. Most faculty are not prepared to face these challenges, and they need, for this reason, to adapt to the evolution of technology. And they must become what I sometimes call skilled users of new generations technologies. The problem with the new generation technologies, so the new technology pedagogies, the new pedagogies that are partly based in technologies, although not all, but these new pedagogies have a problem. We don't yet have books. We don't have books yet and manuals for people to learn them. So they must be learned in papers, in a variety of sources. So this is a bit difficult. And for this reason, it may be useful to have a map of these pedagogies so they can be learned more easily. So I'm going to show you a map of what I call the new generation pedagogies, which I have developed over the last 50 years by analyzing all the kinds of pedagogies that are being explored worldwide in the various areas of education. And I classify them in 6 kinds. The so-called pedagogies of explanation that concentrate on explaining things to people. The pedagogies of empowerment that empowers the students to act. The pedagogies of projects or projects of pedagogies. The pedagogies of socialization, which is the ones that explore collaboration and teamwork and social networks. The drill pedagogies that result from hard training, and the exploratory pedagogies that follow the principles of the creating and developing science. Now, I'm going to visit them very quickly, each one of them. The pedagogies of explanation are the traditional ones, the traditional lectures. So the traditional lectures are the most striking example of the pedagogies of explanation. There are also some variants and narrative pedagogies and so on, but the traditional lecture is the typical pedagogy of explanation. Now, then we have the pedagogies of empowerment. We have lots of pedagogies of dialogue, of blended pedagogies, of blended learning, flipped learning, case start pedagogies, game-based pedagogies, the pedagogies of error, and so on. There are lots of them that, these are just some examples. There are lots of them that enhance and strengthen empowerment and invite the students to become powerful, to develop their empowerment. Then there are the pedagogies of project. We have project-based pedagogies, problem-based pedagogies, design thinking pedagogies, maker pedagogies, and so on. There are also lots of varieties. Then there are the pedagogies of socialization, pedagogies of community, pedagogies, social networking, pedagogies, role model pedagogies, pedagogies of collective intelligence. You have the pedagogies of co-learning and co-evolution and co-assessment. Also have the drill pedagogies that concentrate on intelligent repetition, insistence in intelligence repetitions. The drill pedagogies corresponds to some extent to the transposition to the university of the practice of the athletes. As we know, big athletes who compete worldwide in the Olympics and worldwide competitions, they practice, and they practice. They keep practicing. And there are lots of pedagogies that are based, intelligent pedagogies, not just repetitive, but intelligent pedagogies that insist on this, on intelligent repetition of intelligent practice. And then there are the exploratory pedagogies of simulation and pedagogies of discovery, where the students behave to a large extent as if the way they were scientists developing their scientific projects. So this is the whole universe of the new generation's pedagogies. I've been working on this, and I've been writing for each one of those varieties. I only presented here some of them, but I am developing for each one of those varieties some 4 pages for each. They are all together at the moment some 38, and I am writing about 4 pages for each one of them, so that we can have a whole view, a whole picture of the pedagogies that we can use in our classes to teach for the new generation of students, and in particular the new generation of engineers. Now, when we look at this university, you notice that the tradition lecture is here. And my claim is that the tradition lecture is much overvalued in our universities. And then we have all this, and all this is very undervalued or ignored in our universities. Sometimes we use blended learning, not so much, but sometimes we use blended learning. Sometimes in some topics we use case study pedagogies. Sometimes, and not so that much, we use game-based pedagogies, but we use very little of the pedagogies of empowerment. Then for the pedagogies of project, we'll use very little project-based pedagogies, very little problem-based pedagogies. We use very little design thinking. We use very little maker pedagogies, where we have maker laboratories where the students develop open-ended projects, exercising their abilities in these pedagogies. By the way, projective pedagogies are also empowering pedagogies. So when we develop projects, when we put students in charge of projects, we are also developing their empowerment, but we are also contributing to the development of their autonomy. In fact, those two areas overlap a lot. Then there are the pedagogies of socialization, pedagogies of community, of co-learning, of social networking, of collective intelligence, of co-evolution, of co-evaluation, even evaluation. We don't take opportunity of the prospects of cross-evaluation, for instance, where the students practice pure reviewing of their works. And there's a lot of surprises, very interesting surprises in engaging the students in cross-assessing their work and peer reviewing their work. Then there are the drill pedagogies. We don't practice them at all. And then there are exploratory pedagogies, which we don't pay so much attention to them as well. Now, what is the difference between the traditional lecture and these other alternatives when it comes to skills? Well, the skills developed by these three, especially some of these also contribute, but those three pedagogical areas are very strong in developing the skills we wanted in the beginning of this presentation: autonomy, leadership, resilience, initiative, critical thinking, design thinking. All these skills are developed in these three pedagogies. Very curious, when I started exploring the potential of artificial intelligence agents, assistants, when ChatGPT came out and people started showing their concerns about the challenges ChatGPT and the large language models represented for education, especially for assessment, because in a way they were going to make assessment very difficult. I started experimenting the use of these artificial intelligence technologies with the pedagogies of empowerment, with the pedagogies of project, and the pedagogies of socialization. And they all combine very, very easily with artificial intelligence assistance. So if we want to combine the activity in our universities with the use of artificial intelligence, we should be we should be resorting much more to the pedagogies of empowerment, of project, and of socialization. And this brings us to the conclusions. I made this shorter presentation so that we can talk a bit and discuss a bit those proposals of mine. So my conclusions are that engineering turbulent times breaks down into three categories, three kinds of engineering: traditional engineering, socio-technical engineering, and complexity engineering. And we must be able to prepare our students to act professionally in these three kinds of engineering. In the past, we needed to prepare them for one kind of engineering, which was the mostly deterministic engineering. Now we must prepare them for socio-technical engineering as well. So they must also be able to interrelate with their colleagues and to relate with their stakeholders and to discuss with the people for whom they develop their projects. We must develop these abilities in our future engineers. We must prepare them for complexity engineering. This is the engineering that acts in the area where there is a lot of uncertainty or where there is a lot of disagreement, and they must be prepared for this kind of engineering. And the projects we give them in our project-based approaches to education, we must include a lot of complexity engineering. So this is the three kinds of engineering we must prepare them for. Finally, as it comes to the questions of deployment and of getting to practice and exercise this in our universities, we must develop a cultural transformation of the engineering education. So transform the culture of the environment so that it covers those 5 aspects that I pointed out earlier. And we must carry out this profound pedagogical transformation, which I just described in this universe of pedagogies, in this map of pedagogies, where the ones on the right, the ones that have to do with empowerment, with project, with developing projects, and with collaboration and social collaboration are important. So in essence, this was what I had to tell you. This is a lot. I'm sorry I had to put so much in a single presentation, but I tried to go a bit faster so that we can now discuss them. I've put the slides I've put them on ResearchGate, so I'm giving you this link. If you want, you can get them, and the slides are the top piece of work I have there. And I also have here a QR diagram. So if you have a mobile phone and you want to point it here, you can also get to my page on ResearchGate and download. You can freely download the slides. And that's basically it. So now I suggest we discuss it. How can I do?
So, thank you very much.
Okay, sorry,
We have time for some questions, please. Maybe it's better.
I won't go too fast.
Come here to speak to the microphone, maybe.
Hello, António. Good morning. It was nice to hear your presentation. I have just a quick doubt. You used a word that is interdisciplinary. So you combine different disciplines. But if we look into the building of training, of education, we see that most of the times everything is divided into disciplines. So for instance, when you go into, let me say, assessment of someone career, if you want to apply for a higher position, you look for what this person has done in a specific discipline. If you talk about engineering education as a field of inquiry, no, either you have education science or you have engineering. So the cases for collaboration or interdisciplinary are very rare. They are the exception, not the rule. So what do you think should be the path to make interdisciplinary the rule and not the exception? Thank you.
Thank you. Well, that's the conflict between two paradigms. One is the traditional Cartesian paradigm of dividing to reign. We must, and that's clearly the traditional Newtonian approach to science. That's divide the science. In science in general, we need, in traditional science, we pick up a problem, we divide the problem in small problems, we solve each problem and then put things together. That's the tradition. What's happening now in complex realities is quite the opposite. In fact, just before our century, in 1998, the UNESCO asked Edgar Morin to write a book about the challenges for education in the 20th century. So we were in 1998. And Edgar Morin wrote a book about the future of education. It was published in 1998, and it's published. And they said the future of education is about complexity. The big challenge of education for the 20th century is to prepare people to think in multidisciplinary or interdisciplinary terms, because reality is not made of parts. In fact, if we only look at the parts, we don't get the whole. I'll give you an example, a very simple example. Consider water. Water is made up of oxygen, which is a gas, and we have hydrogen, which is a gas. And we put those two gases together in specific conditions, and they become a liquid. Where is the liquid in the parts? By confining our practice to the parts, we are losing the properties that results from combining the parts. The water, the liquid property emerges. It's in complex systems and which in multidisciplinary systems, we explore the complexity, and we could explore the properties that emerge for the combination of various parts. Without combining these parts, we don't get the properties that emerge from the parts. So this is why project-based learning is so important, because in projects, you can engage in projects that combine lots of challenges. And in fact, there are already some universities that, Stanford, for instance, and some experiments in that area, where you develop projects that combine very different, it even combines science with humanities or science with arts in a single project. And then the assessment of this project is also multidisciplinary. So the challenge is to get people together and start exploring. This cannot be done from one day to the next. This must start being done slowly, but it must be done. We must start to be able to combine the various disciplines and to work on them simultaneously so that we can get the whole and not just the sum of the parts. I hope I...
Thank you for your answer. I think it was very interesting and all the talk. Any other question?
Hello, good morning. I'm José Fonseca from the Nova University of Lisbon. And my question for you is the following. Classes and professors come from the last century where the knowledge was either on books or on the professors. Nowadays, it is not anymore. So there are wonderful resources online, as you know. There is generative AI and all that stuff. So my question is, does it make sense to have classes nowadays? Are we teaching or are we just motivators or advisors of the students? Shall we teach them or shall we motivate them? Because they can learn by themselves. There are wonderful resources for learning. What they need is motivation. That's what I feel. So shall we be, does it make sense to be professor anymore or just in that this just is not just, okay? Because it's probably much more difficult. Motivators and advisors. Thank you.
Well, it's a very interesting question. I think we must teach differently, but we must still act as teachers because there are lots of problems with autonomous learning. One of them is discipline. Most of the people don't have enough discipline to learn by themselves. And then there's orientation. That's advice in journals. And in the beginning, for instance, you need to give a lot of advice so that they can make the good selections because they, of course, they can select by themselves, but there are lots of selections that they are not mature enough to make. So I think our importance lies very much in our maturity. We are much more mature. We have much more experience about the endeavors of learning. And so I think we are needed. I also think we are needed for another reason. We are needed because we are human. We are a human presence because we have emotion. And the emotion is important for, maybe you remember a book by, I cannot remember the name. Megatrends, the author, well, let's think about Megatrends. I cannot remember the author of Megatrends, but it was a book that was published some 60 years ago. And he said that one of the megatrends, one of the trends of the future would be that high technology would call for high touch. That is, in a world that's very technical, people need a compensation, and this compensation must be emotional. So we must bring our emotion, our human profile to the interaction with the students. To motivate them, we must be very good leaders in the sense of passing a message and giving example. For instance, giving example is extremely important also for ethical preparation. To give the example is very important. So I believe that professors are as important or even more important than in the past, but with a completely different role, with this role of deciding with the students, discussing with the students projects, in fact, discussing with them the use they will start making of artificial intelligence, because they are going to need to use it very much. They will need to engage in discussions with ChatGPT and equivalent assistants, but they need some human presence, some human profile that can motivate them and give some sort of compensation. I hope I.
Okay. Thank you very much. I just would like to say that I definitely agree with you. And I also believe that we are essential for learning, for teaching, but in a different way, as you said. So thank you very much for your answer, because I really feel that we have a different role nowadays and it will be different in the future. So thank you very much, because I definitely agree with you. Just to tell you that I think it's much more difficult to motivate and to be a leader than just to teach. So our role will be more difficult, because when you want to teach ethics, for example, you must be ethical. And when you give emotions, you want to be emotive. And I'm sorry, but I have many colleagues that have no emotions. And okay, I will not talk about ethics.
Yes. Yeah, and the emotion and the feeling economics and everything. We have several research on this topic mixed with the technology. So yes, it's very important to put everything together. Our emotion and the feelings. It's important, not just the robots and everything. So it's important to put the emotion with the technology, because we are human, and it's the communication with humans. It's very, very important, and how we transport to the students is important. And we have time for one more question, if you have time, because we are already, it's running out of our time. But
Maybe you can tell me your question. Okay, my name is Rui Lima from University of Minho. Thank you very much for your talk. It was really interesting. And I would like to be able to carry on a conversation about the things that you have presented. But selecting just one question, I would ask you, what do you think about teacher development and teacher training? If you have some ideas or recommendations that you could share with us to help teachers to develop to these new pedagogies, as you call. Thank you.
Yes, I have very strong ideas in that respect, because I don't believe in training, in sitting teachers or sitting professors in a room and training them. I don't think that works. I think that teacher training needs to be an ongoing project. It needs to be a discussion. Maybe it's worth describing something very unusual that happened when we had the pandemic. When on the 13th of March, we received the news that schools would be closing on 14th of March, 2020. There was a group formed on Facebook. It was called e-learning Apoio. I think it was the name of the group. And this group started receiving the membership of teachers from all over Portugal. And this group, which started on the 14th of March, 3 months later, had 30,000 teachers helping each other. So they were teaching online because they hadn't been forced to teach online. And they were just discussing on this group and asking for support and asking for help. And it was really amazing, because I did the experiment myself, with coming, for instance, at 11 o'clock in the evening, asking a question to the group. And I would get an answer in a few minutes. I would get an answer to my difficulty. All the difficulties that were put on the group were responded by someone, by some of those 30,000 people. The group still exists. It's called e-learning Apoio. And now it has 38,000 teachers, I think. But that's an example. The best way for people to train themselves is to train in the context of their difficulties, and to try to be to try to learn something, and if they have difficulties, they need to have a space where they discuss. They have a collective space where lots of people are there and can help. So I think the big challenge to train teachers for this is to create a sort of social network where people can help each other. I don't know if that satisfies you.
Yeah, it's the saying we could continue to discuss with you with pleasure, but unfortunately we are going run out of time. So thank you very much your presentation. I think you opened some issues, some questions what we can discuss in the during the conference, because it was very interesting and very important issues what you told about, and thank you very much for your kindness to let us for us available your presentation. So it was very kind. Let's
Thank you. It was a pleasure for me, and I wish you a very nice and very exciting continuation of your conference. Best wishes for you and for the conference.
Thank you. And now we are pointing, I'm not sure, so yeah. Encerrar aqui, sair da reunião.